And I think it's probably wise if maybe we all get a note card or a piece of paper that's the size of a note card, and we start keeping track of our formulas, because we're actually going to get a new one today. I think we'll have time to get another one today. So there are going to be more of those, and it's probably best if we're doing track of them. So far, we have 2 formulas, but one of them you probably don't even think of as a formula because you've done so many problems. You know that if you're finding the 10th term, what do? We're finding the 10th term. We take the starting term, right? And we multiply it by the ratio raised to the 9th power, right? So formally what that looks like is this. So you're welcome to write that down. Don't let it confuse you. It's what you've been doing over and over and over again. No. Then yesterday we learned about this formula, and we're going to practice it some more. We're going to practice this one today. But what does that formula do? The S should be your clue. What does that one do? It finds the sum. So if you have a geometric sequence, this formula gives you one of the numbers in the sequence. This formula actually adds all those numbers up for you, right? Okay, so we have just those 2 so far, but we are going to be adding to that. So you're going to make yourself a note card that you're going to bring with you every day, or if you don't have a note card, that's fine. Make a piece of paper the size of a note card, and you're going to start keeping track of these formulas so that when we have a quiz, our next quiz, we'll need this formula on it. And I'm not going to give you the formula. You're going to have your note card with you, right? So maybe it's right there with your calculator. Maybe you tape it to your calculator case or something so that you have it. But anyway, that's what we got so far. Okay, so we're on problem 7, which is on the back side of our first little note sheet there. And we have this sequence. Everybody with me? Right, in a minute I'm going to ask for help here for some of you to come to the board. But let's run through this one and remind ourselves what we do. Okay, so we are on the back of the first note sheet I gave you. It's actually just page 2. We're on the back of page 2. We're on problem 7B. Is that right? 7B? That's what I wrote down. Find the one. It's your note sheet. Yeah, that one. The one we write on every day. That's probably it. All right, so here we go. First question says, find the 8th term, so that would be A sub 8. And the second question says, find the sum of the first 8 terms. All right, how do you find the 8th term? You guys are good at this. You're super good at it. Anthony?
You would take the number 6, and you would put 2, because it's 6 times 2. And then you would put 7.
Exactly. So Anthony says, this is a geometric sequence. We're getting from term to term by multiplying by 2. That's our ratio. So we take the first term, which is 6, times 2 to the 7, right? And then we type it in on our calculator, and everybody's got one now, so we can all type it in together. So make sure you're doing this right. 6 times 2 to the 7 is 768. And when in doubt about how to type something in, almost always just type it in exactly as it's written. So if this is what you wrote down, type that into your calculator and it will be right. Okay, now, the sum of 8 terms. Okay, so we're looking at our formula. Q, you awake? Okay, we're looking at our formula. Someone tell me what to write. There's your formula, here's your sequence. What am I gonna write?
First term.
Okay, what's the first term?
6.
6 minus 6 times 2 to the 8, very, very good, over 1 minus 2. Now, what was my hint to you yesterday? Well, but go ahead and do the denominator, so that's not going to be confusing to you later. So we're just going to have 1 minus 2, that's -1, that's easy. But then, yeah, Sean, just like I wrote it. 6 minus 6, parentheses 2 to the 8. I got -1530. Which, of course, when we divide it by -1, is just going to become positive 1530. Would everybody type that in along with me, please, and make sure you're getting 1530? You all got calculators today. Let's type it in, make sure that's what we get. Okay? 2, -6, 18, -54. All right, here we go. We want the same stuff. We want the 8th term. Ria, what's the 8th term going to look like? Can you tell me what to write? I want the 8th term.
2.
Actually, -3, yep, -3.
To the 7.
7, that's right. There, that's it. That's it. And that's how I'm going to type it in. I know I probably don't have to remind you of this, but where do we get the negative? Down at the bottom, right? Please don't use the minus. Don't use the minus, the subtract button. Use your negative button right down here. All right, so 2 times -3 to the 7th. Did you get -4374? Okay, now I want the sum of 8. Okay, so Solomon, what's that going to look like? I'm going to be using my sum formula now for this series.
All it would be is 2.
Talk loud, I'm old. 2
-2.
minus 2, that's an actual minus, that's a subtraction.
Parentheses
-3
-3. 7.
to what?
7.
Actually, be careful. See how that and that are exactly the same?
Oh, there's no minus. Okay. So
Yeah, in this formula, it's not -1. In this form, it's the same thing.
Alright.
So the 8 over 1 minus -3. All right, everybody looking good here? So I'm going to go ahead and do my denominator. My denominator will actually now be 4. And typing in my top, 2 minus 2, -3 to the 8. I got -13120. I'm counting on support from the crowd.
Yes.
That's so awesome to hear. I'm going to divide by 4, and the answer to this question is -3280.
Yes.
Is that okay? You ready to go? All right, on your own, on your paper with your neighbor or by yourself. Let's see if you can calculate these. We're finding the same kind of problem. We're finding the 8th term and the sum of 8 terms. Anybody got number 1 or A done?
Yes.
What'd you get, Anthony?
I got 114,000.
So did I. 7 times 4 to the 7th is 114688. Sean, is that what you got?
Yeah.
All right, you got the second one done, Sean? All right, what'd you get for the second one? 152,000? 915. I have no idea. Let's work it out and see if Sean's right. Anthony's nodding. Anybody else think this is the answer to the second one? Is he? Looks good. Let's go right through it for those people that might need it. The sum of 8 terms, according to our formula, says 7 minus 7 times 4 to the 8th over 1 minus 4. Does that look okay? All right, my denominator is -3. What's on the top? Oops, that's not right. -4,58745. So when I divide that by -3, I get Sean's answer. Any question about that? Everybody got it? We're going to do exactly the same thing now, but we're going to do it with a word problem. 8A. When a student started kindergarten at St. Cathedral, tuition was this much per year. Tuition increased 4.2% per year. How much was the 8th grade tuition? So we're just looking for a term, right? Now be careful. You might be tempted to say A sub 8, but remember we started in kindergarten. So it'd actually be the 9th year, wouldn't it? Hasn't this kid been in school for 9 years? Right? So we want the 9th term. With word problems, it's a little bit trickier. Sometimes you really have to think about, you know, exactly how many terms you're talking about. We have the 9th term. All right, what are we starting with? 1567? What are we multiplying by if tuition is going up 4.2%? Lauren? Exactly. 1.042. So one more time, we got to get this straight. Tuition is going up. So we take 100 and add, well, how much is going up? That gives me 104.2, which decimally is Lauren's number. What power am I raising that to? The 8. So this kid, when he is in 8th grade, is going to pay $2,177.76. Now, when you read that problem, does it make sense to you that we were looking for a certain number? All right, now read number 2. How much did the student pay altogether for K through 8 at St. Cathedral? What does the word altogether mean I'm going to have to do? Sum, which means I'm going to use this formula, right? Now it's still K through 8, so aren't I going to sum up 9 of them? 9 years? So what's the sum of 9 years going to look like here? Yes, you know, use your formula. 1567 minus 1567 times 1.042 to the 9th over 1 minus 1.042. Now stop a minute and make sure that looks okay. These numbers are a little different, but the idea is the same. My denominator is going to be -0.042. And if I'm not comfortable doing that in my head, I'm sitting there with a calculator, figure it out. That's your denominator. Well, what's my numerator? Not sure. Please type it in exactly the way I wrote it. Did you get negative 702.2297423? Now there's no need for you to write all that down because it's on your calculator, right? And you're just gonna hit divided by negative 0.042. We're not gonna retype that number in. It's sitting there, just hit divided by this, and what did you come up with?
16,719.76.
Exactly. So you see how what we are doing can be applied to a real problem? All right, now get the notes I just gave you, the next installment. The ones I just gave you. It starts with Sam on page 3, eating a candy bar, and he's not here to pick on, so we'll have a laugh at his expense. Everybody keeping up?
Yes.
All right, let's look at what's going on here in this problem. Sam ate 1 candy bar. Every day after that, he ate twice as many as the day before. So if he ate 1 on the first day, he ate 2 and 4 and 8 and 16. He's eating twice as many. So he's not doubling his candy bar consumption. So we're multiplying by 2. So our ratio is 2. Macy? You getting it?
Oh, wait.
Every day he ate twice as many as the day before. So I'm multiplying by 2. Right? Okay. Number 1. How many did he eat on the 12th day? How many did he eat on the 12th day? What am I looking for there? A sub 12. I want to know how many he ate that one day. I'm not adding them. How many candy bars did he sit there and eat on that one day? So what does that look like, Hannah?
It's doing 2,048.
Well, okay, maybe, I don't know. What does it look like equation-wise?
A sub 12 is 1 times 2 to the 11th power.
To the 11th power? Yep, that's right. And is that the number you said, probably? Yep, 2048. And it is a word problem, so we'll say candy bars. 2048 candy bars. Number 2, how many did he eat, oh Lord, in the first 20 days? How many did he eat in the first 20 days? Now, do you understand that even though the word altogether isn't written in there, it is certainly implied? So we are going to be adding 20. This is going to be a lot of candy bars. All right? So the sum of 20 candy bars. Q, can you tell me? It's this formula right here now, the sum formula. What's it going to look like? 1 minus 1. Mm-hmm. 20th over. Perfect. So this time my denominator is just a simple little -1. And my numerator, I'm going to type it in exactly the way I wrote it. I told you it was big, negative 1048575. So 1048575, let me put some commas in there, that's 1,048,575 candy bars. You would probably die if you ate that many candy bars. I don't even
20
think
days.
you
I think you should eat that same. Well, let's go like this side. This
Sam
one
will
is
45.
Put your phone here.
Imagine buying that many though.
All right, everybody, let's not worry about what kind of candy bars, so we're really not relevant. Does everybody understand the difference between finding a term and finding a sum? Okay? No, there's a little bit more. All right, so now we are going to get another formula, and I actually left space this time to write it down, but we're going to do some more money problems. Now, I know that we've done some, but every problem we've done so far has been like, Susie gets a 6% raise every year, or Billy gets it every week, or something like that. Now we're going to talk about compound interest. Do all of you have a bank account? Oh, I hope you do. I hope you all have a bank account. And you know what happens when you put money in the bank? It grows. Why does it grow? Because the money gives you, or the bank gives you interest.
Very little.
And I know, right now it's very little.
My bank account.
But the interest is compounded differently depending on your particular account. For most of you, it's probably compounded monthly, although there are accounts that compound quarterly and daily and annually. You can have any kind of compounding. The formula for that, again, you do not need to memorize this, but you need to be comfortable using it.
Is this another formula?
This is a formula. Yep, so it's going to go on your note card. You're going to write it in your notes here. And this is the formula. You're going to label it compound interest. So anytime the problem mentions compound interest, you're going to use this formula. We haven't had that in any of our problems so far, right?
Right.
So unless the problem says compounded quarterly, compounded whatever, we're not going to use this formula. This formula is used when the word compounded is in there. Okay? Now, let's talk about what all these letters mean. This is the amount at the end of the problem. So this is the amount of money that you're going to end up with. P is the amount of money that you start with. Now, anybody want to take a wild guess why it's called P? Anybody know the real name for that? It's called the principal. The principal. The principal is the amount of money that you initially invest. That's called your principal. Okay? That's a 1. R is the interest rate. And this time, kids, it is the actual number. So, if it says 6%, then you write 0.06. The 1 plus is included in the formula. The 1 plus is part of the formula. So you just put 0.06. You will never use this formula if you are depreciating, because nobody puts money in the bank to lose it. The value of the money is always going to go up. So it's always going to be a plus, 1 plus. Now, the 2 n's in the problem are the same thing. And N is the number of times you compound per year. So, if we are compounding monthly, N would be 12. If we're compounding quarterly, N would be 4. If we're compounding annually, N would be 1. So whatever number of times a year you're compounding, that lays here and here. T is the number of years. Time. How many years? Okay, everybody understand what all those letters mean? All right, so here we go. Tex invests $2,000 in an account paying 3% interest compounded annually. PJ invests the same amount at 2.9% compounded monthly. How much will each have at the end of 10 years? So this is two problems. They'll be two separate problems. So let's do Tex first. All right, so here we go. How much will he have? Isn't A our variable? How much am I going to end up with?
Yeah.
What's Tex's P? 2,000. What is Tex's interest rate? 0.03. What's Tex's N? How many times a year? 1. Texas N is 1. Because annually means once per year. So this is 1. And how many years? 10, right? Now, believe it or not, boys and girls, you can type this in
No way.
exactly as this, with one exception. See this right here? Do that first, make it a 10, and now you can type it in exactly the way I wrote it.
What was it before?
It was a 1 times 10. Now it's a 10. So 2,000 parentheses 1 plus 0.03 divided by 1, which of course is just 0.03, raised to the 10. I hope you got $2,687.83. So at the end of 10 years, Tex will now have this much money. Well, an extra almost $700 is, no, I mean, that's better than nothing, right? Well, it's better you put it in the bank than spend that $2,000. Yep. All right, now, PJ is going to make an investment in the same thing. So PJ says, I'm going to put my $2,000 in an account paying 2.9. So that will be what? 0.029? And his interest is compounded monthly, so his N is 12. And what's his exponent then? Well, watch it. There's two things up there. So it's 12 times 10. So his exponent is 120. Because the exponent is NT. That's 12 times 10 for him. All right, let's see how much money he's got. 2671.92.
Yeah.
Now, there isn't a lot of difference between these two amounts. Would you agree?
Yes.
PJ had a lower interest rate. Why was he able to stay so close to Tex, even though he had a lower interest rate? Because you're compounding more often, which means that your money is growing more frequently in the account. All right, well, we just used the formula a couple times. Everybody feeling okay about it? All right, let's see what's next. Christian invested $400 in an account paying 4.5% compounded quarterly. How much will he have after 16 years? Well, why don't you see if you can write down the formula, or write down your equation that you're going to use. This is Christian now. We want to know how much he's going to have in the account after 16 years. Would you write it down for me? Liam, would you write it down on your paper, sweetie? Liam, would you write it down on your paper, please? I feel like, what's that? What's that? Oh, I can't even think out what it is. The teacher stands up in the front of the room and keeps saying the kid's name over and over again. Bueller. Yeah. Bueller.
That was beautiful.
Get your forks ready.
That would be so good.
It's so dumb.
Can we let it go?
Well, not during math class, but sometimes. All right, you got a formula written down?
Yes.
What's it look like? Let me see, Shiloh. What's this look like? What am I going to write here? How many quarters in a dollar? Yep, that's right. And then what? So that's going to be 64. We always want to have a single number there. If we have 4 times 16, you got to be careful how we type it in. So I like to just do that, get that over with, and now I can type it in. Does that equation look okay to everybody? Mm-hmm. That's pretty easy. All right, let's type it in and see what we come up with.
I sure do.
I got 818.48, which means he over doubled his money, more than doubled his money during that time span. And Liam, even in his asleep state, has just made a pretty profound observation. He said, so wait, if he would have started with $400 million instead of just 400, would he have ended up with $800 million? Yes. So the amount that you start with in this given situation, the growing rate is going to be the same thing. Good observation.
You're never gonna find stuff like that.
What?
You're never gonna count like that.
I was thinking. It's never
Paying 4.5% interest?
Yeah.
Oh yeah, there used to be back in the days. Oh yeah, yeah. Bank accounts easily paid that. You can get CD rates that big, but that's because, like, when my husband and I bought our first house in 1981, we were in the middle of a huge recession back in the Reagan era, the big recession. And interest rates, if I went down to the bank to buy a house loan or to get a house loan, it was 13%. Wow, that's right. So we bought our first house on land contract for 10% and thought we were getting a steal. And now you buy them for 2.5% or something.
That's so crazy.
But
you were getting
the
a
upside of it
steal.
was, if you borrowed money, you paid a big rate. But if you invested money, you also got a good rate.
So how much land did you get there?
What?
How much land did you get in the house? Like,
No. A land contract means that you don't go through a bank, you buy it from the individual himself.
oh, so it's like not buying a car from dealership, but buying a car from somebody.
Yeah, exactly. So the house was on, if you care,
I do care.
about an acre.
Oh, really?
I'll tell you where it is. Our first house was at the corner of 81st and Allisonville Road.
Oh, really?
I know where that
Right on the corner. It's still there. And the big trees in the yard, we planted.
Wow, that's great.
Have grown in 40 years.
I know exactly where that is.
All right, you have successfully gotten me off track. So, we'll here and we will pick up here tomorrow. Okay?